Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about complex consecutive integer word problems. I previously did a video where we did just basic kind of introductory level consecutive integer word problems. So in this video, I'm going to step it up a little bit and we're going to do 3 different examples of some more difficult problems. In this first example, it says find 3 consecutive even integers such that twice the third is 10 less than 5 times the first. Okay, so there's a lot to break down in that sentence. The first thing that we want to point out is that it says that we should, by the time we get our answer, we should have 3 consecutive even integers. So let's break down what that means. Integers means it could be positive or it could be negative, but they're going to be whole numbers. Okay, so we should not end up with any fractions or decimals. If we do, we've done something wrong. The other thing is that they are consecutive even integers. Consecutive means they are in a row. For example, 1, 2, 3, 4, right? So the numbers go in sequential order, but they're even numbers, which means it wouldn't go 1, 2, 3, 4. It would go 2, 4, 6, 8. So that even is going to be very important with how we set up this problem. And then the last important thing in this first sentence is that we are looking for how many numbers? 3 consecutive even integers. That first little part of the sentence tells us our setup. So we are looking for a first number, a second number, and a third number. And it's always good to lay this out kind of at the beginning because it's going to help us structure our problem from here on out. Our first number is our unknown number, right? We have no idea what it is. We know that it's going to be even, but we have no idea what it is. So we're just going to call it x. And this is going to be the pattern for all of these problems. We're always going to start, our first number will be just x. Now our second number, let's think through this. If it's a consecutive even integer, that means we would take our first number, x, and we're going to add 2 to it. So let's think about that. Let's just say x was 2. What would be our next even number? Well, it would be 4, right? And then it would be 6, and so on. So how would I get from the number 2 to the number 4? How many did we add to go from 2 to 4? We added 2. And then how many would it take to get from 2 to 6? Well, we would have to add 4. So that tells us what our third number would be. We start back at the first number of just x, and we're going to add 4 to it. That will give us the next even consecutive number. So now that we have our setup for each of our 3 numbers, let's look at the rest of it. So it says find 3 consecutive even integers, which we've got, such that twice, anytime we see that phrase with these problems, such that, it's whatever comes next is going to tell us what to do with those numbers. So such that twice the third. Which one is the third? Well, that would be this right here, right? And if we want to say twice the third, that means we need to take the third and we need to double it. So how could we do that easily? Well, we just take 2 and we times it by the third, x plus 4. And the parentheses here are so important because we're doubling the whole third, not just the x, not just the 4, but the whole third. So such that twice the third is, that means our equals, so it is 10 less than 5 times the first. So let's think through that. 10 less than 5 times the first. Well, who's the first? That would be our just plain x. So it's easiest if we think 5 times the first, well, that would be 5 times x. But then it's 10 less than that. So that means we need to take our 5 times the first and subtract 10 from it. Less than in this context, it's indicating to us subtraction, but it's what we call a switch word. And what that means is whatever is in front of the word less than gets moved to the back, and whatever is behind the word less than gets moved to the front. So you see how we said 10 less than 5 times the first. We put the minus 10 in the back, and the 5 times the first in the front. So now we've got this equation set up. We just need to solve it using our algebra. And we're going to solve for x. I want to start by getting rid of these parentheses. I need to distribute this 2 into the parentheses set. 2 times x is 2x. 2 times a positive 4 is a positive 8 equals, and then we've got our 5x minus 10. We'll just bring that down. Now from here, I want to get my x's together. Right now they're on opposite sides of the equation. It's always a good rule to bring your smaller x value to the bigger x value. 2x is going to be our smaller between 5x and 2x. So let's subtract 2x over here. And 5x minus 2x gives us 3x. We're going to bring down our negative 10, down our equals, and down our positive 8. So now we've got our x's together, but now we need to get our constants together. So we need to take this negative 10 and move it over to the 8. We're going to do that by adding it. 8 plus 10 is 18 equals 3x. If this is 3 times x, we need to undo multiplication to get rid of that 3. And we can undo multiplication with division. We want to divide by what we want to cancel, so we're going to divide by 3. And what we do to one side, we have to do to the other. So 18 divided by 3 gives us 6 equals x, or x equals 6, same thing. So what that tells us is our first number. We know that our first even integer, x, is 6. Now we can easily figure out our second and third number. So our second number is x plus 2. So what's 6 plus 2? 8. And then to figure out our third number, it's x plus 4. Well, remember x is 6. So what's 6 plus 4? And that would give us 10. So we just found our 3 consecutive even integers. They are 6, 8, and 10. Now we can do a quick check just to make sure that our work is correct. So the first thing we'd want to make sure of is, did we find 3 consecutive even integers? Are these in order? 6, 8, 10? Yes. Are they even consecutive numbers? Yes. So that part's good, but to fully check this answer, we're going to plug it into our original problem. And I think it's helpful to kind of read through the problem again and write now that we know our first, second, and third number. We know that twice the third, okay, so our third was 10, so twice the third equals 10 less than 5 times the first. Well, we said 5 times the first would be 5 times 6, and then it's 10 less than that. Well, 2 times 10 is 20. 5 times 6 is 30. And then what's 30 minus 10? Well, 30 minus 10 is 20. And does 20 equal 20? Yes. So we know this checks out, and our numbers are 6, 8, and 10. Let's look at another example. Find 2 consecutive odd integers such that 4 times the second is 2 more than twice the first. So there's a couple things we want to notice at the beginning. These are odd integers, consecutive odd integers, which means by the time we get our final numbers, they should be integers, whole numbers, and they should be odd. Now, how many are we looking for? It says 2. So this time, we're going to have our first number and our second number. Our first number is always going to be x. Now, our second number, remember that these are odd integers. So again, very similar to even, it's going to be every other number. So let's think about odd numbers. So we've got 1, 3, 5, and so on, right? Now to get from 1 to 3, how many units would we have to add? Well, we would have to add, just like the even numbers, 2. And then what about from 1 to 5? Well, then we'd have to add 4. So notice the pattern here, even though these are even and these are odd, is the same. If they're consecutive even or consecutive odd, the pattern will always be x plus 2. And then if we had more, we could say x plus 4 and then x plus 6. Now in this case, we only have 2 numbers, so we're going to stop here. Okay, so now that we've got our setup with our first 2 numbers, let's look at our such that, because that's going to tell us what to do with these numbers. So 2 consecutive odd integers such that 4 times the second. Okay, well, who's the second? That's our x plus 2. We need to say 4 times x plus 2 is, again, is means equals, is 2 more than twice the first. So if we're going to twice something, again, that means we're doubling it. So who's the first? Well, that would be our just x, right? So twice the first would be 2 times x. Now I don't need to add parentheses here. I mean, you could, but since it's just a one term, it's just an x, we don't have to have parentheses there. But it's 2 more than twice the first. Add 2. 2 more than twice the first. Okay, so now that we have our equation set up, we just need to solve it using our algebra rules, and then we'll be able to figure out what x is, and therefore our first number. Okay, so we need to distribute this 4 into the parentheses. So 4 times x is 4x, and 4 times a positive 2 is a positive 8, equals, and then we're going to bring down our 2x plus 2. Now again, we've got an x on either side of this equation. We need to get them together. So let's bring the smaller to the larger. So in this case, we'll need to subtract 2x from both sides. 4x minus 2x is 2x. We'll bring down our plus 8, bring down our equals, and bring down our 2. We need to subtract 8 from both sides. We got our x over here, so we need to get the constants to the other side. 2 minus 8, that's going to give us negative 6. We're going to bring down our equals, bring down our 2x. Now we almost have x alone, but it's got this times 2 in front of it, so we need to divide out the 2 to get rid of it. So we've got x equals, now negative 6 divided by 2. That would give me a negative 3. Now remember, it's okay to have negative numbers. Negatives are integers. As long as they're whole numbers, we're good. So we know the first number now, right? X is negative 3. The first number was x, so the first number is negative 3. Now what about the second number? So for the second number, we would want to insert our negative 3 in for x. I'm going to write it out this time. So x is negative 3 plus 2. And what's negative 3 plus 2? Well, it's a negative 1. So what we're saying is our first number is negative 3, and our second number is a negative 1. So first thing we want to do for our check is just ask ourselves, are these consecutive odd integers? And they are consecutive. If we looked at a number line, I know it gets kind of weird once we start throwing negatives in there, but if we looked at a number line, we would see a negative 3 and then a negative 2, and then a negative 1. So these are consecutive odd integers. Now let's do a check to see if our answer matches up. Find two consecutive odd integers such that 4 times the second, remember our second is negative 1 now, so 4 times negative 1 is 2 more than twice the first. So let's twice the first, so 2 times negative 3, but then it says it's 2 more than that. So now let's simplify each of these sides and see if we get a true statement. 4 times negative 1 is negative 4. 2 times negative 3 is negative 6. And then we'll bring down our plus 2. So we've got negative 4 equals negative 6 plus 2 is negative 4. So does negative 4 equal negative 4? Yes. So now we've checked our answer and we're sure that our two consecutive odd integers are negative 3 and negative 1. Let's look at one more example together. Find 3 consecutive integers such that the sum of twice the second and 4 times the third is 25 more than the first. But the first thing that I hope that you noticed is it didn't say even or odd. It just said find 3 consecutive integers. So what that tells us is this pattern would be like going, and I'll just kind of do it over here, would be like going 1, 2, 3, and so on. To start with the first number and get to the second number, we only have to add 1, because we don't want every other number, we just want the numbers in order. And to start at the first number and go to the third number, we would just add 2. So what that tells us is, for this pattern, we've got 3 numbers we're looking for. So we've got the first, the second, and the third. We know the first one is always going to be just x. The second number, looking at this pattern and thinking about it, is just going to be x plus 1. We just want the next number. And then the third number would just be x plus 2. Now that we have our numbers laid out, let's unpack our such that statements. So we've got 3 consecutive integers such that the sum of twice the second. Okay, so there's a lot of key words here. Let's point them out. Sum means to add. So that means we're going to be adding. We're going to add twice the second. Remember, twice means to double something, to times it by 2. So twice the second. Now, who is the second? It's x plus 1. The sum of twice the second. And what are we going to be adding to it? So the sum of twice the second and 4 times the third. So our third is x plus 2. So if we wanted to say 4 times the third, we would just say 4 times x plus 2. Again, parentheses are so important. Then it says it is 25 more than the first. So is means equal. 25 more than the first. Well, who's the first? The first is x, right? But it's 25 more than x. So we need to take x and add 25 to it. So the sum of twice the second and 4 times the third is 25 more than the first. So now that we have our equation written, we can solve this for x, and then we can easily figure out our 3 numbers. Now this time we have 2 parenthesis sets, so we're going to need to distribute twice. We're going to need to distribute the 2 into the first parenthesis. Let's go ahead and do that. 2 times x is 2x. 2 times 1 is a positive 2. And then we'll need to distribute the 4 into the second parenthesis. So 4 times x is a positive 4x. 4 times 2 is a positive 8. And it equals x plus 25. I do recognize that I have an x on both sides, but look, I've got 2 of them over here. So this is a situation where we definitely want to do some like terms combining over here. So we've got a like term of 2x plus 4x. Those are like terms that we can go ahead and combine. They both have an x. And then we can also combine these constants. Look, because we've got positive 2 and a positive 8. So let's go ahead and do that. 2x plus 4x is 6x. 2 plus 8 is a positive 10. And then we've got our equals x plus 25. Okay, so now that we've got all of our like terms together, let's take the smaller x and move it to the larger x. So we're going to do that by subtracting x from each side. Now 6x minus x is going to be 5x. Remember, there's an understood 1 in front of that x right there. So this is really 6x minus 1x. So 5x plus 10 equals 25. So we want to subtract 10. We want to move everything away from our x now. 25 minus 10 is 15. Bring our equals down, bring our 5x down. And now our last step to get x alone is divide by 5. So x equals 15 divided by 5 is 3. Okay, so we found our first number. We found x. X is 3. So now what would our second number be? So our second number is x, which we know is 3, plus 1, which would be 4. And then our third number is x, which we know is 3, plus 2. So 3 plus 2 is 5. Okay, so we're saying our answer would be 3, 4, and 5. Let's think through this. Are they all integers? Are they all whole numbers? Yes. And are they consecutive integers? Are they one right after the other? 3, 4, 5. Yes. So now we just want to do a quick check to make sure our actual numbers are the right ones, that we didn't make an error somewhere. Find 3 consecutive integers such that the sum of twice the second, okay, so we've got twice the second, well, we know the second number is 4. So 2 times 4, and we're going to add that to, because we said sum, 4 times the third, well, the third is 5, so 4 times 5 is 25 more than the first. Well, who's the first? It was 3. So we're going to add 25 to 3. Okay, so let's simplify these two sides and see if we get the same answer. So 2 times 4 is 8, plus 4 times 5 is 20, and 3 plus 25 is 28. 8 plus 20 would be 28. And does 28 equal 28? Yep. All right, here's one for you guys to try. I will post the answer in the video description below. This has been Miss Smith's Math Tutorials.